about the non-homogeneous wave equation for rectangle. But firstly, I will explain to you about the derivation of wave equation. For derivation of wave equation, we usually will focusing on the string problem, which is the u equal to deflection of the string in vertical direction at given time t and given location x. We have to make the several assumptions such as mass per unit length, no resistance, gravitational force negligible, string performs small transverse deflection, and vertical deflection are small as slope are small. In here, as we say the slope are small, we can just assume t1 cos alpha equal to t2 cos beta equal to t. For vertical direction, we can use the formula of force, which is F equal to ma, which is F is t2 sin beta minus t1 sin alpha over t. Ma here, we can just use density delta x over t and del squared u over del t squared. From here, we can just separate it and we can just use the t that we already assumed before and replace it with t2 cos beta and t1 cos alpha. In here, we can just cancel the t1 and t2. We can see that here is sine over cos. Sine over cos, we can just replace it as tangent. Next, the tangent beta is the slope of string. We can just assume it to be del u over del x based on x plus delta x, and tangent alpha equal to del u over del x based on x. We just have to substitute this tangent alpha and tangent beta here and we will get this. We have to divide this by delta x and we will get this. This is basically just del u squared over del x squared here like this. And we just have to rearrange it and we will get this. Del squared u over del t squared equal to t over density del squared u over del x squared. Here t over density is always positive. So we can just assume that E will be c squared. And here we will get the 1D wave equation. For the non-homogeneous wave equation, there will be another force here, which is the external force. And this is the wave equation for non-homogeneous. Next, my friend will explain to you about what is non-homogeneous wave equation. That's all for me.
Explain about what is non-homogeneous wave equation. Non-homogeneous wave equation is when the right-hand side of the wave equation is not equal to 0. This is the equation for non-homogeneous wave equation. As we can see here, this equation is not equal to 0. utt minus c square uxx equal to fx, which is fx can be any function of x. This is the initial condition for non-homogeneous wave equation, which is fx is the initial displacement and gx is the initial velocity. For the boundary condition, if x equal to 0, we will get A, and B if x is equal to L. We can solve this non-homogeneous wave equation using method of separation of variable. Because of the initial condition is the function of fx and gx, we need to redefine all the initial condition and boundary condition and separate the equation into two systems. After using the method of separation of variable, we will get this general equation for non-homogeneous wave equation, which is Vxt is equal to summation of n equal to 1 until infinity an cos n pi ct over L plus bn sin n pi ct over L sin n pi x over L, where an is equal to 2 over L integration of fx minus ux sin n pi x over L dx, and bn is equal to 2 over nlc integration of gx sin n pi x over L dx. So the next presenter, we will show how to use the method of separation of variable.
Wave equation for a rectangle. So this is the form of non-homogeneous wave equation. We have utt minus c squared uxx is equal to fx. It is called non-homogeneous because it have fx here, have the boundary condition and also the initial condition. Firstly, we assume that uxt is equal to vxt plus ux. So u we differentiate 2 times toward x, we will get vxx plus u double prime. and then we differentiate again towards t, we will get utt equal to, and we substitute back into, we will get utt just now is vdt minus c squared, and then uxx equal to vxx plus u double prime is equal to fx. Then we bring the c squared u double prime into the right hand side. By this we know that the left hand side, if we equal to 0, we can solve it as we solve homogeneous wave equation. So by this we have two systems. We have system 1 and also we have system 2. And also we need to redefine the boundary and initial condition because just now we assume that uxt is equal to vxt plus ux. Firstly, we substitute 0 into t, so we got vx0 plus ux is equal to fx, and the second one, we need to differentiate towards t. If we differentiate it towards t, we will get v equal to gx, and u0t is equal to v0t plus u0 is equal to a, and ult is equal to vlt plus ul equal to b. The system one is c squared u double prime plus fx equal to 0, and then we bring fx to the right hand side, and also c squared also we bring it to right hand side. We integrate this one, we will get u prime, and then if we integrate this one out, we can let c squared to the outside because it's just a constant. So we integrate fx will be we will get fx dx, integration fx dx, and also a constant a. We integrate it again, so this will be gone, the integration onto the prime. So we get u equal to negative 1 over c squared. We double integrate fx dx, we get this. And also if we integrate a, we will get ax and another constant b. And negative 1 over c squared double integration fx dx, this one. And if we multiply negative 1 over c squared and ax, we will still get ax because a and c is just a constant. Same goes to b, and so we just name it as ax plus b minus 1 over c squared double integration fx dx. So this is for system 1.
Now I will continue to explain the method for solving system 2. As we have the general equation v equal to summation from n equal to 1 until infinity in bracket an cos n pi ct over L plus bn sin n pi ct over L multiply with sin n pi x over L. So for now we have to find the value of an and bn. So we need to calculate them. In order to obtain the value of an and bn, we have to apply the initial condition. As you can see here, we substitute the value of t equal to 0. Hence, for v with t equal to 0, we will obtain the general solution of summation from n equal to 1 to infinity of an sin n pi x over L, which also equivalent to fx minus ux. So here we can obtain the value of an, which is the formula of an is equal to 2 over L integration of 0 until L of fx minus ux multiplied with sin n pi x over L dx. While on the other hand, we apply another initial condition, which is Vt with the value of t equal to 0. Hence, when we substitute the value of t equal to 0 into Vt, we will obtain the equation equal to summation of n equal to 1
until infinity Bn sin n pi c over L multiplied with sin n pi x over L equal to Gx. Hence, if we rearrange this, we will obtain n pi c over L Bn equal to 2 over L integration of 0 until L of Gx multiplied with sin n pi x over L dx. Hence, we can obtain the value of Bn, which is the formula is 2 over n pi c multiplied with integration of 0 until L of Gx sin n pi x over L dx.
So this one is our example with the condition of the boundary condition is 0 and also our initial condition when the t is equal to 0. So we need to find for our uxt. So now we are going to let the uxt is equal to the vxt plus wx. We derive the uxt to find the uxx and also utt, and we sub to the original non-homogeneous wave equation, and we will get this one. So we let the left hand side is equal to our v equation, right hand side will be our w equation, and we let these two equations become 0. So these two equations will be get. After that, we solve for our boundary and initial condition. This is given by the equation, and we know that after that we sub the condition to our equation. The uxt is equal to vxt plus wx. We will get the behind one, and the vx0 will be our x squared plus x minus 1 minus wx. So now we are going to solve for our wx, and we need to sub to the equation to the vx0 later. So firstly, we solve for our w. We integrate w prime x equal to 2. So we get the wx is equal to our x squared plus as plus b. The a and b will be our constant. We use our condition in here, these two, to find for our a and also b, and we will get the b is equal to 0 and a is equal to minus 1, and this is our wx is equal to x squared minus x. This is our first equation. So now we are going to sub the wx into the vx0, this one, and we will get the condition of our v equation. So after we sub into this equation, we get the vx0 is equal to 2x minus 1. Now we are going to solve for our v. So from the homogeneous wave equation, this is a homogeneous wave equation. From the homogeneous wave equation, we will get the formula is equal to this one, these three equation. And now we are going to solve for our an. So firstly, we solve for our an, and I separate this into 3 terms. So I integrate separately, will be more easier for me to calculate. Okay, after I calculate these 3, and then I start back to the an, and I will get this one for our an. Now we are going to solve for bn. Oh, sorry, this one is for the, this one I use the fx, right? X squared plus x minus 1 is from the condition, the initial condition. And also this gx, for the gx is 0. So for the bn, we will get 0 when we integrate 0. So I will get 0 here. After that, we start back to the vxt. And this is our an. And since our bn is 0, so just ignore. And then we will get cos and pi t, sine and pi x. So from the beginning, we know that we let the uxt is equal to vxt plus wx. So now we sub the vxt and also wx to the uxt, and we will get this as our final ust. So that is all for me. I hope that you really know how to find the uxt from the non-homogeneous wave equation.
We'll discuss on the wave equation, non-homogeneous wave equation today. And for the question below, you can see that the wave equation is non-homogeneous. And to solve this question, first we're assuming the solution is involving the eigenfunction of sine n pi x. We are wish to find a uxt which is the sum of n equals to 1 to infinity of unt sine n pi x, and we use the hxt to replace the non-homogeneous function which is the xt, and we also find the hnt by using the formula. And to note that our L is to be 1 and our L is to be 1 here. And we also find the UTT and UXX and further substitute it into our non-homogeneous wave equation. And our U lambda here is negative. Our lambda here is n pi. And by the uniqueness of Fourier series, the coefficient of n must be matched so that we can just use the un double prime of t plus with un of t n pi squared equals to hn of t, and we found it by using the MUC. We found the homogeneous solution and the particular solution, and by using that, we found out the C value is to be 2 times with the negative 1 power of n over with the n pi cube, and D is equals to 0. And we also, by using the MUC, we can find out the UNT is equals to A cos n pi t plus B sin n pi t minus with the C times with the t. And to find out what is the A and what is the constant of B, we need to use the initial condition to solve it. And we found out, at the last part, we found out the A equals to 0 and the B is equals to 2 times with the negative 1 of n over with n pi 4 plus with 2 times with 1 minus with negative 1 power of n over n pi squared. And we finalize all the answer and we substitute it into the UST formula, and we will get the final answer there.